hello from my side. Thanks for having me here. Lots of new faces, but we will see what I will be up to. My name is Christian Schöpp. I'm the product owner of ACO0. I work for the Austrian registry, nog.at. All right, who doesn't know where Austria is? Here's a quick introduction. I travel a lot, so when I'm in Asia or so, it's always quite hard to explain where I am. But I think for you guys, it's pretty simple. nog.at, as I said, runs the Austrian registry. We are like 9 million inhabitants in Austria, and we have 1.5 million domains under registration. We are having 70 employees, split in 2 offices, one in Vienna, in the capital, one in Salzburg. I work in Salzburg. All right, what I'm doing here, why I'm here. We are one of the, I think, newest members of TREX, and I will explain why we're here, what we do, how we do it, what are the challenges, and last but not least, I have a little recommendation for you, but we come to it. Okay, so what we do, we run, with ACO0, we run an authoritative DNS service. This service is primarily for other registries, but also for our customers, for registrars, or for customers of customers. Well, who doesn't know what the Anycast service is? Basically, Anycast is using the same IP addresses on a bunch of nodes for redundancy reasons. Right. Okay. Why we did it? nog.at runs the registry, and the registry is a monopole. Well, a monopole is quite nice because the customers come to you automatically, but we realized that you cannot rely on this forever. So like other registries, we started to diversify. We made a lot of side projects, a lot of side businesses, and ACO0 was one of the most successful ones. Technically speaking, we did this to have a more redundant service and the same experience all over the world. Okay, so let's jump into it. Basically, the service is quite simple. We receive the zones from our customers. We distribute them around the world. We try to keep them in sync. Basically, there is the most magic happening. We answer the queries, and then we get a lot of data, logging data for statistics generation. Very simple. In pictures, it looks like that. The green stuff is what we do. The red stuff is what the customers are doing, and the yellow stuff is how we get the things. So no big magic. Basically, there are 2 products, one for TLDs, second for other businesses. The main difference is how the data is split. For the TLDs, there's a few zones and a lot of delegations. For all the other businesses, there are likely millions of zones and a few delegations. Right. If you run a service like that, you need to run a lot of nodes. The question is where you place your nodes, and there's a couple of optimizations you could do. But those are quite contrasting. You can go, for instance, to a country with a lot of population, India, for instance, 1.5 billion people. Well, but if there are no customers there, it might not make that much sense. You could place a node where there's a lot of traffic. Well, traffic depends on with whom do you peer, and again, where your customers are. Or you can place a node where you want to have the best speed, or where the lowest costs, or simply be smart and put it there for tactical reasons. We see later about that. So you see a lot of contradicting things, so we ended up with around 90 nodes around the globe. The node in Tampere, I've put the graph on here. This basically, the first interesting thing, I think Raymond asked me that, well, we started peering, I don't see your traffic. This is pretty simply explained because DNS traffic is measured in kilobits per second and not in gigabits per second. It's pretty low. But due to the nature of DNS traffic, this is quite important because it's the start of pretty much of every communication. So what we see around here, the green traffic I would call is the good traffic. Well, this is a useful query which has been answered. The blue and the red stuff is not so good traffic. Well, we come later to that. Okay, Tampere, the node we're running here, we call a local node. Local node means we do not attract traffic outside of Finland. Local node also means we need to do peerings with you guys, so we are always happy when we find a root server, because a lot of peerings come with that. The issue is with the big guys, we need to do this individually, and this is always quite some work. The root server itself, from our point of view, we don't like them so much because it's a lot of work and we don't get much traffic. So in the big picture, it won't help us. But it is mostly for the country. So you have a server now with us. We do the backup for .fi. If something's going on, something's bad going on in the world, the Finnish server will be still working and serving the zones here. So this is more or less a courtesy to Trafficom, which is one of our customers. Right, if you run a service like that, what is important? Well, first of all, the performance, measured in milliseconds, the faster the better, of course. What uptime to achieve, is your service available or not? And last but not least, if you do an update on your zone, how long does it take to be propagated around the world? Right, if you run a service and you want to have good performance, you can have 3 strategies. First strategy is, well, you can place nodes everywhere. Well, this is what the really big guys are doing, like Cloudflare or whatever. On really almost every point of presence, they have a node. They simply don't need to care. Or you are a small one and you simply put out a few nodes and it's good enough. Or like we are, you smartly select your nodes and try to optimize as good as possible. I would say most of the competition is in the on point 2. Right, this is what it looks like. This is from a measuring tool. Basically, you see the performance in milliseconds around the globe. Main message here is we aim for the best performance in Europe and the United States, since most of our customers are there. If you have other focus, maybe someone else is doing better. Right. Coming to the second KPI, uptime. Well, DNS has already quite some nice built-in redundancy. Basically, it goes like that. If I query nog.fi, I get a list of 5 name servers. Those 5 name servers are spread with different vendors on different places. And the resolvers, they get this list. They try to figure out which of those servers is the best. They have all some kind of magic inside, which even I think scientific papers are written, so you don't exactly know which resolver uses which authoritative name server. But anyway, they rank them somehow and they distribute the traffic. Meaning, if one of the name servers go down, well, another one steps in quite easily. So this is quite nice. But there are sometimes routing issues. Which means there is a black hole, so traffic to our nodes is lost or from our nodes is lost, and the thing is we don't see this, right? The node is up and running, the node is attracting traffic, it's not reporting any fault because it cannot see this by itself, and this happens like every 3 months. So, well, what helps you? What can you help? What helps you with that is look for redundancy, look for other vendors. All right, in the TLD world, it's quite standard to have more than one vendor. For instance, we in .at, we have 4. We are with the University of Vienna. We use our own product. We use NetNode, and we use German guys. So whatever happens out there, if someone or even 2 have a problem, the .at zone is still up and running. And most are doing that. For our registrar and ISP products, this is a little bit different because some rely just on us. So we came up with 2 different clouds, which has different routing strategy, different transit provider, even different infrastructure. Some are virtualized, some are not, to give more or less the same kind of redundancy. Well, this is what it looks like in the real world for redundancy. There is no 100% bar because this is measured end to end. Right? This is, I think I spoke someone today from RIPE. This is more or less the same measurement they are doing. Yeah, in Germany, or in German, we have a saying, it's called, wer viel misst, misst viel Mist. It basically means if you measure a lot, you measure a lot of nonsense, and measurement is always influenced by the point of view. I'm telling you this because not everyone understands the basic principle of the difference of UDP and TCP. UDP might get lost, as you know. UDP is not ICMP. My most favorite customer is somewhere in Asia. They do a ping from their office location to our nodes, and they automatically report us when pings are lost. Well, it's pretty nice. You get a lot of tickets in the ticket system, but actually all what they are doing is they measure their own internet connectivity and ask us to troubleshoot our server. Well, good luck with that. We answered to have, by having outsourced the measurement and made this public. Well, they can always check if something is going on or not. Good. Generally, if you run an Anycast server, you always want to have the traffic as local as possible for performance reasons, to have load balancing, and this is the prerequisite to scale up. Well, let's have a look what bad optimization would look like. You have nodes spread around the world, but you're somehow attracting traffic from parts of the world you don't want to see. Picture should be more like this, all right? But this is not so hard to achieve. Let's have a look what is going on there. We need to do really a lot of traffic engineering on each and every node. We need to figure out if we want to announce our prefix or not to transit or peers. We are heavily relying on path pretending. I think I got somewhere the question a couple of weeks ago, hey, why you guys are pretending 4 times, something must be wrong. No, it's not. I'll explain you a little later. We are heavily using BGP communities, and we're troubled by some asymmetric routing as well. So, and you can imagine 90 nodes, and in each and every of those nodes, we need to make those decisions, and we need to fine-tune this constantly. Right, the individual peering, they simply do not scale. Well, we love root servers, once again. And once we're finished with optimizing, well, it starts again. Somewhere, always, something is broken. Okay, let's jump into the prepending stuff. Well, there's a picture on that. Let's say on top there is whatever, a global ISP provider. And we have, on the right side, we have the node in Tampere. On the left side, we have also a node. And if you would not prepend, what would happen? All the traffic is going to Tampere, wherever it's coming from all over the world. And this will break the experience for our users, and this is what we need to avoid. The solution is quite simple. We prepend one time in Tampere, and suddenly the traffic is going the right way. So this is just a small picture, one node here, one node there. Again, we have like 90 nodes. So we needed to make the path globally for all our nodes the same length. And we have a volumetric DDoS protection as well, booked with one of the big guys. So we ended up with 4 times pretending and an AS path length of 5. So this is what it is right now. Quite interesting magic. Yeah, in real life, we're troubled by a few more things. The incumbent, like here in Finland, is usually the key player. They don't want to peer with you, but on other locations, there might be just a small player, and they need to peer with others. And if we would not react on that, they would attract the traffic on places we don't want, so we need to block them. Right? So one more thing which makes our life pretty hard. Okay, while we're here at Trex, as I said, because Trafficom is our customers, by ourselves we would not come to internet exchange simply because of the overhead and the little traffic. We like to use a provider because there's a lot of things included like peerings and transit already. All we need to do is shape traffic a little bit with the PGP community. But whenever we are invited, this is a good opportunity, and it works quite well. Okay, let's jump into some challenges we're having. Basically, our service is troubled by quite a lot of attacks on two layers. The first is volumetric attacks, which is, well, not so interesting, I would say. More interesting is, from our point of view, are attacks on the application layer. Well, quick recap. Volumetric attack, well, it's garbage traffic which fill your node or your link. Basically, the main message here is, if this is happening somewhere, our nodes detect this. They kick in the DDoS protection, and our prefix is announced on a different place, scrubbed, and anycasted back to our nodes. The interesting thing here is that speed is not really influenced. In some places it gets even better, in some it gets worse. Okay, let's jump to application layer attack, meaning DNS queries to our nodes, which those volumetric DDoS protection provider cannot filter out because it's valid traffic, just bullshit traffic. Well, those traffic, actually, I don't know the percentage, but only parts of it are real attacks. Other parts are configuration mistakes, or even some research is going on our servers. There are two kinds of attacks, or two kinds of answers. The first here in red is, well, if you query for a subdomain, I put here an example, 123xyz.nog.fi, to our servers. Well, the server has the responsibility for serving the zone nog.fi, but it simply doesn't have the answer, but it knows that it doesn't have the answer. All right. And those guys, they do this in a smart way. They always put a random subdomain, third or second level. By doing so, they prevent caching on our side, and this makes it quite costly for us to answer those things. The second thing is the blue stuff, the blue traffic. Well, they just use our name servers and ask them anything. Well, we know we're not responsible for that. We simply tell them, well, you've come to the same place. Same result, traffic for nothing, right? Those attacks gives you quite an factor on a good day with standard traffic. On a bad day, it's a factor 100 to 1000, and you need to size your infrastructure for that kind of traffic. And this makes it quite challenging for individual corporations, for smaller customers, and even for us. So size matters. More nodes, more stronger nodes, and yeah. One interesting thing is, if you get an attack, you might say, well, it's good to have a lot of nodes because traffic is spread out over the world, and all of those nodes can help together. But this is not true all the time. Sometimes traffic is quite focused, and only one node gets the traffic. Well, then you would say, well, that's a bad thing. The node gets all the traffic and it dies. Yeah, this eventually might happen. But from a global perspective, this might be not so bad as well, because only one node dies somewhere in the world, let's say, I don't know, some country in Africa, and the rest of the world is functioning just fine. Yeah. Okay, so let's have a look what this would look like on a per zone basis or per domain basis. On the top, there is a big European train operators website. They had a not so important website forgotten to be protected, and they had serious troubles. What happened? They came to us. The bad guys, they tried 2 more times, and then they gave up. Right? The amount here is like 5 billion queries on one day. On the top, there is another example. This is a German governmental domain, or 2 German governmental domains. They were already protected by us. And you can see the bad guys, they tried to increase and to fine-tune their attacks. They got bigger and bigger until they finally gave up. Right. Let's have a look what such an attack will look like from the node perspective. This is a node which is actually receiving two different types of traffic. The first is with the big blue blocks, and the second is with the spikes in the end, and at some time they're even overlapping. This is roughly factor 100 to normal traffic, what this node is having, and the node need to deal with that. Well, the same attack we saw on a different node somewhere else. All right. Which one you think is closer to the source? Is the left or the right one? Alexi?
The left one is closer to the source.
Yeah, that's true. Because on the right one you see a lot of, let's say, good traffic, the green bar, and it looks a little bit mutilated, right? So if you read where it's coming from, so the left is from Moscow, the right is London, and you have a look on the network where the traffic is coming from. This is Yandex, so most likely most of the traffic is coming somewhere from the Russian area, right? Okay. The thing is, well, in this case, we saw most of the traffic is coming from Yandex. You could say, well, just let's block Yandex on IP level or network level or whatever. Well, you could do this and say, well, I don't care what is going on with Yandex. They simply cannot resolve all those things we are serving. But imagine if this is Google or Amazon or Cloudflare or whatever, because most of the attacks and bad traffic is coming from those big guys. We can't simply just block them, because a lot of real customers would have problems. So what we need to do, we need to answer on those. So IP filtering or some other filtering is not an option. Honestly, I don't even know, and I don't care so much who is the target. We see the traffic and we need to deal with it. We don't even know if the source of the traffic has anything to do with the attacker. Yeah? In this example, we have seen the traffic is coming from Russia. Yeah, so what? Could be some hijacked routers in Russia used for an attack to London. We don't know. Generally speaking, this blue traffic is usually, but not all the time, some configuration mistakes. The NX domain, the red traffic are usually real attacks. We don't know, to be honest. Yeah, last but not least, some fun facts. We have millions and millions of zones, but most of the zones are never queried. And we have the most queries for zones that do not exist. So very interesting business, but it is what it is. Okay, final point. For you guys, I think you most are really hardcore technicians. This might be very simple to understand, but believe me, every couple of weeks or so, I see someone in tears knocking on my door, which are doing the same mistakes, and I explain what they're doing, and maybe one or the other from you finds time and talk to someone in the IT department yourself. So basically, if you run DNS yourself, it would look something like that. You have at least 2 authoritative name servers, because you want to be super secure, you put a firewall in front. But the thing is, or the mistake many people are making, if there is a lot of traffic, they want to somehow shape the traffic or want to know what is going on, and they configure some rules on the firewall. And this breaks the firewall, because you get hundreds of thousands or millions of requests per second, and no firewall, whatever, can lock this or continue with connection tracking. So if you do something like that, please do not log or inspect DNS traffic, meaning port 53. Well, lots of you are smiling. Yeah, this is really simple, but again, this is a mistake a lot of people are doing regularly. All right, so if you want to be super safe, outsource it, like the Trex guys did it. If you want to be even smarter, well, look for a name server inside your network, which is not reachable outside. And if you outsource it, the final words, look for someone, or look at least on the price list what they're charging for traffic. A couple of billion queries a day cost you quite a lot of money already. All right, that's it from my side. If you have questions, I'm happy to answer them later on. Okay then.
Thank you, Christian. We have time for a couple quick questions, if people have any. No? Okay, thank you again, Christian.